Okay. Tell the camera what you're going to write.
I'm just going to do the title first.
Oh, write the title. Just write it. I'm not doing a school transition. And then you can introduce it, and then we'll do the transition. You've been to drama school.
Okay, so
I've been to drama school, so I should
I'm
know.
trusting my production techniques to you.
Yeah.
Okay, so vector subtraction. What we're going to do is take our ideas from vector addition and just tweak them a little bit so that we can do vector subtraction. And the reason we're doing this is because this is going to allow us to calculate the change in a quantity, like the change in velocity or the change in momentum.
Yep.
Okay, so the key thing, we do example of change in velocity is final velocity minus initial velocity, but this can apply to any quantity. The change is always the final one minus the initial one. Remember, for vectors, the key thing is that the negative sign reverses the direction of the vector. We can use that to change subtraction into addition. So for example, 5 minus 3. What we're going to do is change that into an addition problem by making the minus sign a plus sign and reversing the direction of the second vector. It's really important that we associate that minus sign with that vector, not with this one. So 5 plus 3. 5 plus 3 we can do. We're just going to add them together nose to tail. And we're pretty happy that we're going to draw the resultant from the tail of the first one to the nose of the last one, and the length of that must be
at least 1.9.
At most 2.
That's 2.9.
let's call it 2, shall we? Let's extend this idea out then to going around a corner. Say you're going around a corner and you're going along to start with. Example number 2. Okay, so example number 2, kind of a little bit of a take it circular motion and thinking about going around the corner and just choosing 2 points in circular motion. Moving along the corner and then moving down the corner. Constant speed, right? Circular motion. It's really tempting to think that the change in velocity is going to be 0 because it's 12 metres per second and 12 metres per second. Why isn't the change in velocity going to be 0? Because the direction of the vector's changed, eh? So we must have, to get this answer here, we've stopped the left-right motion and started the motion in the y dimension, up-down motion. How do we calculate the change in velocity?
Nose to tail and
Triangle B equals
So change in velocity is which one minus which one?
probably the one going down minus the one going sideways.
Yeah, good. The final one. So it's 12 minus 12, but we have to get it the right way around, right?
You just put it the wrong way around. Oh, you didn't. My bad.
What do we do next?
Probably got to switch them around a wee bit so they're facing the same direction.
Same direction? Hypotenuse. What do we do? What do we like minus
Oh,
6?
we add them nose to tail to add them.
We need to add them. How do we make that into a plus?
We switch that to the other side.
Which one?
Switch the one on the left to be on the right, don't you?
No,
Flip
that
the
one, flip it.
Yeah, the right
Don't
one.
switch it, but flip it.
So it's going to be the same as 12 plus 12. Now we do the.
24.
How do we add vectors? How do we do that?
Nose to tail.
How do we add actually it doesn't matter. Addition is commutative, so it doesn't matter if we go 12 plus 12 or 12 plus 12. We're going to get the same answer either way. Doesn't work for subtraction. Subtraction, the automatic is 5 minus 3 is not the same as 3 minus 5. But 3 plus 5 and 5 plus 3 are the same. So, 12 and 12, who knows what you get when you go 12 and 12? What do we do the resultant? How do we do the resultant?
Is it 16.97?
So we got 17-ish meters per second, and when we're trying to work out which angle to calculate, we generally calculate the angle between, it doesn't matter as long as you label which angle you're calculating, it doesn't matter what angle. I would calculate that one, the angle between the initial vector and the resultant one. We could have drawn our other two vectors, we could have drawn those two, and then we would have ended up calculating that angle. So it's a little bit arbitrary. How do we calculate that angle? What's our trig function that we use?
Well, that was easy because both sides are 12, so it's 45.
Tell us.
So small.
What would we do if we were going to use a trig function? Which trig function would we use? Tan, right? We find that tan theta is O over A, and that theta is antitan of 12 over 12, which is 45 degrees.